Hey guys, welcome back to another episode of Physics Problem Solving with Captain Hook. Today we're going to talk about levers. We'll go ahead and read through the problem real quick, which again, like always, you can see below the video here. Then we'll talk a little bit about levers and then see how we can solve it. Okay? So it says, if I gave you a lever arm that's 10 meters long, where would you have the rest of the fulcrum to lift a 1,000 kilogram object off the ground? So I'm going to say, just to make it easier, we'll use my mass of about 72 kilograms. Okay? So we'll get back to that in 1 second. Levers are actually a really clever way of moving something heavy that you wouldn't be able to move just by pushing on it. They're used in many places in our everyday lives, including your skeleton. A lever consists of a lever arm, which is a free to pivot about a point, or fulcrum. It relies on having a distance, L1, that is much larger than another distance. So we're going to just draw a quick picture real quick. So we'll have our distance, which is here L1, which gives our fulcrum there. And we have a second distance, L2. So what it allows us to do is if we push down on this end of this distance, it's going to lift that side up. Well, it's going to take a lot less force to push down here to make that side go up than what you would actually need if you were to lift it up or something like that. Okay. So basic lever equation. Again, you have a force where you push down there. We'll call it F1. And then we have F2, which is sort of going up like that, okay? So our basic lever equation is simply F1 over F2 is equal to L2 over L1, okay? So in this case, what we need to do is simply solve for what this distance needs to be. If we know that our mass pushing down here is 72 kilograms and our mass going up there is 1,000. Okay? Now, in this case, the force due to this is simply due to gravity. So we're going to set up our equation. First we'll set up the ratio. We already have L2 over L1 equals force 1 over force 2. Well, in this case, our force 1 is just the mass of one thing times gravity over, well, force 2 is just the mass of the second object over times gravity. Now in this case, if you can't tell, gravity is going to cancel out. So we're simply going to be left with a combination of our masses. So that's going to cancel with that. So we're going to be left with mass 1 over mass 2, sort of gives us our ratio. Okay. So if we plug that in, L2 over L1 equals, well, our first mass is 72 kilograms. That's my mass. No fat jokes, please, today. Over 1,000 kilograms. And that gives us a ratio of about 0.072, which if we make it look a little bit better, we know that L2 equals 0.072 times L1. So that's our ratio we want to start with. Okay? Now we already know that the entire beam, the entire length, is 10 meters. So we want to know exactly where that fulcrum wants to be. Okay. So to do that, we know that, again, I'm going to move this around real quick. We know that, I'm just going to rewrite it. Our length of 2 has to be 0.072 times our length of one side. And we also know that L1 plus L2, our two lengths, have to be 10 meters in total. Okay. So what I'm going to do is I'm going to just subtract L1 to the other side. So that's going to be, subtract L2 to the other side. So that's just going to be like L1 equals 10 meters minus L2. And I'm going to plug it back into our original equation. So we plug that back in up here. We get L2 equals 0.072 times, well, 10 meters minus L2. Okay. And if we do a little bit of math there, we get L2 equals, well, multiply those together. That's 0.72 meters minus 0.072 times L2. And then we're going to just add that to the other side and simplify. So we'll do L2 plus 0.072 times L2 equals 0.72. Well, that gives us 1.072 times L2. Just doing a little bit of math real fast. 2. We divide both sides by this 1.072. L2 is about 0.67 meters. So if we go back to our original picture, that means that this has to be 0.67 meters. So to figure out what L1 is, we just take 10 and subtract it. So L1 equals 10 minus L2, which we solved up there. So L1 equals 10 meters minus 0.67 meters. So our long length, which has our payload on it, or our load, has to be 9.33 meters approximately long. So those are our two lengths. And the fulcrum has to be placed between those two. That's pretty amazing, thinking that using something like this, I can lift something that has a force of about 10,000 newtons, if we're using 10 for the acceleration due to gravity, even though my body weight only gives a force of about 720 newtons. It's pretty crazy.